Section B, Oblique Plane 2010 B3. The graphic on the right shows a skyscraper which is located in Miami, Florida. The front face of the building contains a curved recess as shown. Draw the given plan and elevation of the building. Complete the elevation by drawing the curve on the front face of the building. Determine the horizontal and vertical traces of the oblique plane that contains the front face of the building. Determine the true angle between the traces. We're going to start off drawing our XY line and drawing our plan. We'll draw as much of our elevation as we can, given the information. We'll notice that these lines are hidden here as they're at the back of the model as we look in elevation. These two lines here will not exist either, as they are the two lines contained here in our SolidWorks model. That is the first part of the question. To draw this curve here in our elevation, I have chosen to take horizontal cuts across in our plan. We could also take vertical cuts or inclined cuts, but horizontal cuts were chosen for this drawing. The first horizontal cut I'm going to take will contain the top of the recess curve in our plan. So you note that's the red line here. Carry that up to our elevation. We're going to draw in that cut. So we notice our cut over here on our SolidWorks model is contained as an edge view here in our elevation. We're going to carry up our middle point, and that is going to give us a point on the curve. We're going to take a second cut across. Again, it is shown as an edge view here in our elevation, which is this cut here in our SolidWorks model. That's going to locate 2 points, one which is here and one which is here. So our 2 points are located here in our elevation. Finally, we're going to take one more cut across, a horizontal cut again. You'll note there that this cut here is contained as an edge view here in your elevation. That's going to locate 2 points, one here and one over here, which are going to give us 2 more points in our elevation, and we can draw in our curve as shown. For the next part of the question, we're asked to draw an oblique plane that sits against this face here of our object. We know that that oblique plane will be contained where this surface comes in contact with the ground here. So we'll have our horizontal trace. If we join this point to this point and extend that onto our XY line. To find our vertical trace, what we'll have to do is locate a point here on our oblique plane, carry that to a vertical plane, bring it up, and we bring it across. So we'll take this point here, for instance. We carry that up parallel to our HT, and then we bring the point across in our elevation and up from our XY line. That is given as a point here on our oblique plane, and that is going to give us our VT, our vertical trace. So we could do this with any point we have on our oblique plane. So we'll see here in our SolidWorks model, this is our oblique plane here, and our trace is where this plane comes in contact with our horizontal plane and our vertical plane. This is the vertical trace, and this here is our horizontal trace. The next part of the question asks us to find the angle between the two traces. So all we have to do there is rebat our oblique plane down onto the horizontal plane. We're going to be able to find that angle. So we bring a line up from our XY line anywhere until it hits our vertical trace. We carry this out perpendicular to our horizontal trace here, as our horizontal trace is going to act as our hinge line. All we do then is we take this distance here and we tick that off with our compass out here, and that is going to give us the angle between our two traces. So in essence, what we have done is we have folded this oblique plane here down onto the ground, and that is going to give us our angle between the two traces. That is the question complete. 2010 B3.